Going on now to the PowerPoint slides of section 7 of chapter 5. Now keep in mind I already have the additional exercises done, and they're below in this series of videos. So here we're going to look at equations containing sums or differences of cubes. So to solve equations, remember, the only method we have in our toolbox so far is factoring. So we'll need to factor the sums or differences of cubes. Now there's actually a recipe for doing it, and that's what I will show you. And let me go over what they have here. We'll use this as a basic example. So this is a perfect cube, and this is the sum. Perfect cube, this is the difference. Now the recipe for doing it, and you'll have to take some notes on this probably, is you put a set of parentheses for two terms and a set of parentheses for three terms. So one's a little smaller than the other. And this is the same for both of them. Now you look here and say, what's the sign there? So whatever sign is there, you put right there. What's the sign there? Right there. Now there's another sign that's in the middle of the three-term parenthesis. And the rule is it's the opposite sign of what you put here. Here it was a plus, so here it's going to be a negative. Here it was a negative, this will be a plus. Now these others are positive, so they're not involved. Now what do you do? Well, you take the cube root of this term, and that's A, and the cube root of this term, and that's B. Now we kind of don't pay attention to this for a while. Next part of the recipe, that's the same down there, by the way. You square this term right there. You multiply these two terms together, and that makes up your middle term. Now notice you would think it should be a positive, but this other rule has precedent. If this is plus, this will be minus, but you multiply these. Then you square this term. And that's exactly the same for the other. And we'll see some examples, and you may want to go back and take some notes on this. Okay, let's start off with this one. So a parenthesis for two terms, a parenthesis for three terms. Now, next, what's my sign here? That goes right there. What sign do I put here? Opposite sign. Now, I take the cube root of that, which is going to be x, and the cube root of that, which is going to be 3. Square this term, multiply these two together, and again, it's kind of an enigma that you have a plus here, but again, it's opposite this sign there, and then square this term. And that's the recipe. And these are the factors of the difference of perfect cubes. If you were to FOIL or multiply this, long multiplication, you would get this. And they're doing something similar. Okay. All right, let's do this one. Now this is the sum of perfect cubes. Parenthesis for 2, parenthesis for 3. What's the sign? You put it there. And then opposite sign here. Cube root of that, cube root of this, square that, multiply these together, and square that. Notice it's exactly the same as the difference, except the signs are reversed here and there. Okay. And that's it. So we've done this, and we have that. And that's the recipe. That's the factorization. Okay, now it gets a little more complex, but that's okay. Again, there's no common factor to take out of both of them. So parenthesis for 2, parenthesis for 3. Negative sign goes right there. Opposite sign right there. Now we don't worry about signs anymore. This is a perfect cube. Cube root of that is 3x. Cube root of that is 2y. Square the first term. Multiply these two terms together and you get 6xy. And square this. And that's the recipe. Again, you need to try it and with practice, and then later on your quiz me's. Okay, how about this one? Now, notice, is there a common factor in both of these terms? And the answer is yes, right there. I could take a 3ab out of each term. So here I'm left with b cubed plus a 3 out of there is 64, and I have a to the third, b to the ninth. And now I'm wondering just what they want me to do here. Theoretically, I could take, I'm going to leave it like this, but theoretically I could have factored out b to the third, b to the fourth out here, and then that would be, in fact, let's do it that way. I think that's what they wanted me to do. I probably should have looked at what's coming next. Okay, these are still perfect cubes, but now I factored out completely. Okay, so we need to write this again. Parenthesis for 2, parenthesis for 3. And cube root of 1 is 1. My plus sign goes there, my negative sign, opposite sign goes there. All right, the cube root of 64 is 4. 4a. And the cube root of this, just divide by 3, it's b to the second. Now we square 1 and we just get a 1. Multiply these two together and we get 4ab squared. Now square this and this gives us plus 16a squared b to the 4th. Almost ran out of room. I went too far there. Okay, well, let's see what they want. I'm assuming it's this one. Yes, we did that. And yes, they wanted you to take that out. Okay. And that's it. That's what we had. Okay. So here we have a couple of special products. The sum of cubes is this. That factors into this. The difference of cubes factors into that. And notice we had also from earlier sections the difference of squares. They factor into, what are these called again? They're conjugates. Okay? There is no formula for factoring the sum of squares. They're just telling us that. So now they want us to solve this equation. Well, actually, there's a couple of ways to do it, but if we do it by factoring, I'm assuming that's what they want us to do. Put it in standard form. This is now standard form, equating it to 0. We factor this side, and we get this. Now, this number here does not factor using real coefficients. So this comes out to be imaginary numbers. But this factored very well, and we're going to factor that or equate this to 0, which is what they show right there. This doesn't. So here we get x is a 4, and we have one solution, but we could find some others by graphing them, which we don't require a graphing calculator, and that will be it. Remember to look at the work that we did on the additional exercises.